Hello everyone, this is the 7th video of Chapter 3, Solve Systems of Equations by Graphing. In this lesson, you will solve system of linear equations by finding the point of intersection. To begin with, we need to know what we mean by system of linear equations. Systems of equation is when you have two or more equations with the same set of variables. In order to find the solution of the systems of equations, you will need to find the point of intersection that satisfy both equations. Number 1, solve the system y is equal to negative 2x minus 3 and y is equal to 2x plus 5 by graphing. The first step in here will be graphing y is equal to negative 2x minus 3 first. From the last lesson, this is following y is equal to mx plus b form, where m is representing the slope and b is representing y-intercept. In here, that tells me the slope is equal to negative 2. My y-intercept in here is equal to negative 3. The second equation, y is equal to 2x plus 5. In this case, your slope is equal to 2, where your y-intercept is equal to negative 3. When you are graphing, you will begin by plotting y-intercept. And then the second step will be you're using the slope as rise over 1 since we're graphing. And then the last one, once you graph two equations, you will find when they're intersecting. So the intersecting point is your answer. The first one, let's graph y is equal to negative 2x minus 3 by plugging in. Negative 3 is going to be my y-intercept. And in here, they're saying my slope is negative 2. So if you have negative 2 and I want to use rise over run, since they are not the same format, I want to make negative 2 as a fraction. If I do so, this means you will have negative 2 over 1. Since my rise is negative 2, I'm going down 2 and you are running 1 to the right side. So here's 1. The next one. Now, I cannot continue anymore. If you want to know what's happening on the other side, what I can do is instead of having negative 1 denominator, I'm going to make 2 over negative 1. Because eventually 2 over negative 1 will be still negative 2, so I'm not changing my number. In this case, you're going up 2, and since run is negative, instead of going to the right, now I'm going to the left. You'd realize my lines will still be straight, and that's how you can check whether you did it correct or not. Let's just continue. So I'm going up 2, left 1, up 2, left 1, and up 2, left 1. When you connect all of them, they will form a straight line. And then I can draw arrows on each side. The second equation, y is equal to 2x plus 5, they also have y-intercept of negative 3. And technically, that's going to be your intersecting point. But anyway, we'll just continue. And since your slope is 2 and I want to have rise over run, it's similar to your number 1, you're going to put 1 underneath, which means I'm going up 2, right 1. And you just continue up 2, right 1, up 2, right 1, up 2, right 1. If you want to know what's happening on the other side, since this number is already positive, if you want to change it, if you want to put negative on here, you have to have another negative on the denominator, so that way when you're simplifying this, negative 2 over negative 1 is still positive 2. In this case, you're going down 2, and since run is negative 1, you're going left 1, and still you'll form a straight line. As you're connecting them, I see that they're intersecting at this point right here. So that's how I know this point is going to be my solution. You actually found this from the beginning when you were plotting negative 3, but I just wanted to show you how to graph with two lines. In here, your answer has to always follow x, y format because it's a coordinate. My x value is 0 and my y value is negative 3. And this is the solution of your system of equations. Let's practice similar questions like number 1. In here, if you're solving a system of equations, again, first step, you need to graph y is equal to x minus 1. And the second step will be graphing y is equal to 2x minus 2. Since this is following the slope-intercept form, your slope in here, let me write m, is equal to the number in front of x, which is 1. And your b value is going to be your negative 1. In this one, m, your slope is equal to 2. Your b value is going to be negative 2. To graph, you are going to begin by plot y-intercept. Number 2, use slope is equal to rise over run. And then find the answer of x, y, where when they're intersecting. In here, the first one, since your y-intercept is -1, it goes on here. And since slope is 1, if I use this as rise over 1, this will be 1 over 1. You're going up 1, right 1, up 1, right 1, and continue until you can't. If you want to know what happens on the other side, since this is +1, if you want to go down and to the left side, you will need to have both negatives. So eventually, when you simplify this, -1 over -1 will be still +1. I'm going down 1 and left 1. And just double check if this is still making a straight line. If somehow you have a point over, I don't know, maybe over here or something like this, then you'd realize that these are not a straight line. So continuing, you will have 1 on here, and then rise -1, run -1. Now you have a straight line. For the next part, since your y-intercept is -2, you begin from here. Your slope is +2, so that means you're going to have 2 over 1. I'm going up 2, right 1, up 2, right 1, up 2, right 1. And actually, you would already find the point when they're intersecting. Let me draw the graph first. I don't have to continue because I noticed already that they're intersecting at this point. So this coordinate in here is x is 1 and your y value is at 0. So this is going to be my answer of the system of equations. This time part B, they're saying you're going to have y is equal to 4x. And the second one, y is equal to x plus 3. This one in here, the second equation, is similar to what you just did. Your slope in here will be the number in front of the x, which I don't see right now. It's because they have 1 hidden. Your y-intercept, in this case, will be +3. On this side, if you're looking at the slope, this is equal to 4. For the y-intercept, I don't see any number next to it, which means there is a number that you did not have to write it because it wouldn't affect any of your equation. The number that doesn't really affect anything is when you are adding 0, so I know the y-intercept has to equal to 0. Let's graph this. So plot the y-intercept first. My y-intercept of the first equation is at 0, and from here your slope is 4, so I can write it 4 over 1. You're going rise 4, and you are running 1. Here's 1. Just in case if I want to know backward, you're going to have 2 negatives to make it positive, -4 over -1. -4 over -1 is still +4 when you divide them. So go down 4 and left 1. Now you have a graph. The second one in here, y-intercept is at 3. So you start with the 3 on y-axis. And then your slope is 1, which means I can write it as 1 over 1. You go up 1, right 1. Well, they already have a point of intersecting. So instead of you're trying to figure out what's happening on the other side. If I just connect these two, you would realize that they're intersecting at the point. This point, as your answer, you have to write in a coordinate form. So if I'm writing a coordinate, the x comes first, which is 1, and your y value is at 4. So this is going to be my solution of system of equations. Number 2, Gregory's Motorsports has motorcycle, 2 wheels, and ATVs, 4 wheels in stock. The store has a total of 45 vehicles that together have 130 wheels. Write a system of equations that represent the situation. When I'm talking about the system in here, going back, the system means you will have 2 or more equations. What they're asking in here is so then write 2 equations that would represent the situation. They were talking about 2 different topics. The one was a motorcycle, the other one was the ATVs. One another information is that when you are counting all of them, there are a total of 45 vehicles. Let's say motorcycle will be your X value and your ATVs are going to be the Y value. When you are adding them together, there are a total of 45 vehicles. Also, when you are adding their wheels, they add up to 130. For the X, since X was a motorcycle has 2 wheels for each. So I'm going to have, when you have 2x plus the ATVs have 4 wheels, if you have 4y, when you add them together, they has to make 130 wheels. And let me just write on the side, x was your motorcycle and y is your ATVs. Then they're asking you, solve the system of equations, interpret the solution. In here, if I want to graph this, The problem is the x plus y equals 45 is not the slope-intercept form. In fact, if you remember, this is written in standard form where ax plus by is equal to c. You have to change this into slope-intercept form by having y by itself on one side. If I want to do so, I'm going to subtract x from each side. In this case, x minus x will be gone, so I get y. Y is equal to, you will have 45 minus x, where I'm going to write negative x first, so that way it will follow y equals mx form plus 45. Now this is going to be your slope-intercept form, where the slope is equal to -1, your y-intercept is equal to 45. The second part is, again, when you have 2x plus 4y is equal to 130, you need to solve for y by first subtracting 2x on both sides. This will make 4y is equal to, again, you can write 130 minus 2x, but since I'm trying to make it y equals mx plus b, we will write the negative 2x first and then plus 130. Still, you need to get rid of this 4 because you need to have y equals. 4 and y have multiplication in between. If you want to get rid of the 4, you're going to do the inverse operation and make sure that you do this on each terms. The y will be equal to -1/2 x if you simplify this, and 130 over 4 is equal to 32.5. So let's begin by graphing it. The first one, since their y-intercept is 45, that it will be around here. And from here, your slope is -1. When you're down 1, by the way, you're not going the whole box because each box on the y-axis, it's representing 10. When I'm going down 1, 45 minus 1 will be 44. When you run 1, it's going to be over here. So that's at 1, 44. And continuing, if you go down one more, that's going to be 43 at 2. And continuing this will be a very small graph to do. If you want to do a little bit bigger numbers, if I go down 5, I know this could be confusing. If I divide by 5 again, then this will be still -1. So let's begin from 45 minus 5 and run 5 will be over here. From 40 minus 5 and run 5 will be over here. That's going to be 10,35. Let's do the other one. In this case, if I'm looking at it, 32,5, which is over here. And for this one, since my y-intercept is already a decimal, if you're trying to figure out -1/2 using this graph, it looks quite difficult to me. So what I'm going to do, instead of doing with fraction, I'm going to change this as this is equivalent to -0.5, which means when I go down 0.5, you are running 1. Because it's going to be so small to graph, if I want to do the big chunk, just like the other equation, I want to move right 5, which means I'm going down 5 times. So 0.5 times 5 is 2.5. You will be going down 0.25. So in here, if I want to find what happens when x is equal to 5, you will have 32.5 minus 2.5, you'll get 30 right here. In here, the graph that was given by the textbook might not be the best one right now because I still need more space. So here's another graph that I pull it up. This will be the graph when you have a bigger intervals. In this case, the point that they're intersecting is right here where we only had a graph up to 10. Then that's why we were not able to see the part where they're intersecting. In this case, this looks like it's going by 5. So 20, 25, 30, 35, 40. This is going to be at 25, comma, your y value is 20. And that is going to be your answer of the system of solutions. When you're interpreting this means the x was representing the motorcycle. So you will have 25 motorcycles. When you have 20 ATVs, will satisfy both equations. So for example, 25 plus 20 is equal to 45, what they were asking. And if you had 25 motorcycles, that will add up to 50 wheels. And then for ATV, since ATV has 4 wheels, you will have 80 totals. And when you add them, 50 plus 80 will become 130 as what they're asking. To graph of a system of equations indicates a number of solutions. There will be 3 different cases when you are finding the solution of systems of equations. The first case is when you have one solution. This is the case when you're intersecting. Since they are intersecting at one point, this will be giving you one solution. If they are parallel lines like this, they are not intersecting at all, so there will be no solution. When you graph them and they become just one line, which means they're identical, so this will make every single point be your solution. In this case, there will be infinite number of solutions. Sometimes I will be drawing this sideways 8 as your infinite sign, or sometimes I will spell it out. Number 4 and 5 will be still graphing to see how many solutions you will have. One more time, when you are graphing, the first step is going to be plot y-intercept. The second step is use slope as rise over run. And keep in mind, this will work. The best equation to graph will be always slope-intercept form. And if you don't have a slope-intercept form like number 5 right here, then you will have to change it. Number 4, the first equation, y is equal to 2x plus 1. The slope in this case will be 2, where your y-intercept is positive 1. The second equation is following y equals mx plus b. M is equal to 2. B is equal to negative 3. Let's begin by plotting the y-intercept. The first one is at 1. And using the slope, since they are 2, 2 is equal to 2 over 1 when I write it as a fraction. So I'm going up 2, right 1, up 2, right 1. Again, if you want to continue backward, I'm trying to think how many negatives do I need to make it one positive. If you had one negative like this, they will not equal to positive 2. So I need to have another negative. Negative 2 over negative 1 will be equivalent to positive 2. I'm going down 2. And since run is negative 1, you're going left 1. And you continue this over and over until you can't. Here's one graph. Then the second one, they're saying the y-intercept is a negative 3. And from here, still my slope is 2. So using the same information, you're going up 2, right 1, up 2, right 1, up 2, right 1 until you can't. And if you want to go backward, you're going down 2, left 1, and here's a point. This is the parallel line where they will be never intersecting. So in this case, there will be no solution since they are not intersecting at all. Number 5, similarly, the first step, since I'm using, well, it looks like it's the exact same equation. So m is equal to 2, your b was equal to 1. But in the other case, this is not a slope-intercept form. In fact, this is your point-slope form. So if I want to write a slope-intercept form, again, you will need to have y equals something. Let me add 3 on both sides. Then the second equation becomes y. These two will be 0 is equal to 2x. Negative 2 plus 3 will be equal to 1. So in this case, my slope is 2, b is equal to positive 1. To begin with, if I graph the first equation, your y-intercept is at 1. And from here, you go up 2, right 1, up 2, right 1. And similarly, well, they are all having the same slope. So I'm going down 2, left 1, down 2, left 1, and down to left 1. The second equation is actually having the exact same one. So if even I graph it, it's going to overlap. B is at negative 1. You're going up 2, right 1, up 2, right 1. And you go down 2, left 1, down to left 1. When I connect them, so as you see, they're literally overlapping in every single point. You're not going to write every single point that they're intersecting. Thus, in this case, this is infinite number of solution, which means that they are intersecting at every single point. They're literally identical lines. Here's the last problem. A system of equations consists of two lines. One line passes through 2, 3 and 0, 5. The other line passes through 1, 1 and 0, negative 1. Determine if the system has no solution, one solution, or infinite number of solutions. So we've been practicing the different cases where this one is not giving you any equation. Instead, they're just giving you two coordinates. So here's a one. They're saying if I had a line that passes through 2, 3, so 2, 3 is saying the first one is your x, the second one is your y. This is how we write the coordinates. So on your x-axis, I'm looking at 2. And for your y-axis, it's going up 3, where if my scale is going by 2, your 3 will be right here. That's 2, 3. The second one is at 0, 5. So same thing. Your x is 0 when y is 5. So that's going to be right here. Now let's connect them. Since I have 2 points, I could draw the line. The second line that is saying if you had 1, 1, I'm having x is 1 when y is 1 right here. The second one is at 0, negative 1. So 0, -1 will be over here. If I connect these 2 points, keep in mind your goal is not to find when they're intersecting. I just need to know how many solutions will they have. Since the black line is going this way, where the blue line is going that way, whether if I draw this slightly over here or here, it wouldn't matter because I know that they're intersecting at least once. So in this case, your answer will be they are intersecting at one point. So one solution is going to be your answer. Just to give you a quick review, if you had 2 parallel lines that will never intersect, will be no solution. If you graph them and they are identical lines, then this is a case of infinite number of solutions. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.